Hey folks, Ira here, back for another round of AI analysis via statistics, and today we're cracking open a fresh data set, the US underscore 500 table from Brian Dunning underscore sample data. So picture this, 500 records, 12 columns, all laid out neatly, but it's more than just a basic contacts list. There's some hidden gold in these stats. We've got classic contact details, address, company names, emails, and then all that location data. City, county, zip, state, the works. And what really jumps out right at the start is just how many of these columns have completely unique values for every record. Columns like address, company name, email, last name, phone 1, phone 2, and web, they're all showing 500 unique values each. Super clean, right? Each record is its own little island, at least when it comes to those fields. This is exactly what you want to see in a well-maintained CRM, honestly. It makes data governance and deduplication a whole lot easier. I'm reminded of this time, I think it was a manufacturing client, where we kept running into trouble because their supposed unique identifier was not unique at all. Like 5 CEOs named Jeff Smith with the same company name. Not great. Unique emails and company names can really save your bacon when you're building ETL processes or running data quality checks. Otherwise, you just can't trust your merges. Anyway, one thing I always check, it's almost like a ritual at this point, is just running that distinct count over those important columns first thing. With US 500, you can breathe a sigh of relief for those core identifiers. The uniqueness gives us confidence that, at least for addresses, names, phones, and emails, we're looking at truly individual entities. No double counting or mystery doppelgangers sneaking in. But before I get ahead of myself, let's see how this unique profile starts to shift once we hit the columns tied to location and a few other bits. Now here's where things get interesting. When you flip from uniqueness to repetition, a different picture pops up. So cities, counties, states, zip codes, these columns, they're nowhere near as unique. You see a lot of repetition and clustering. For example, New York comes up 14 times in the city column. That surprised me at first. Then in the county column, Los Angeles jumps out at you with 18 appearances. CA, that's California for the non-standard postal code crowd, that's 72 times in the state field, which is wild considering this is just 500 rows. What's that tell us? The data set isn't evenly spread across the entire US. Instead, it's got pockets, or clusters in certain regions. It's almost like someone pulled contacts from a handful of major metros and then sprinkled in a few others elsewhere. As someone who spends way too much time with data profiling, I see this kind of regional clustering all the time, especially in marketing data. You're trying to design outreach or segmentation strategies, and suddenly you realize 15% of your contacts are just in Southern California. If you're running any AI-driven segmentations or targeted marketing efforts, it's really easy to overfit to these high-frequency regions. Now what's cool, or maybe frustrating, depends on your perspective, is that these clusters can skew pretty much every downstream process. Whether you're building predictive models or just doing simple descriptive stats, if you don't account for that concentration, you're going to draw some weird, sometimes hilariously inaccurate conclusions. That's something we talked about in earlier episodes, the hidden traps in your data that AI and statistical models can stumble over. So next time you're looking for nationwide patterns or hoping to generalize, remember, check for regional repetition, or you'll end up training your model to think the whole world lives in LA or New York. Shifting gears a bit, let's look at those sneaky, almost unique columns, first names and zip codes. Start with first name. 484 unique values in 500 rows, so you only get a handful of repeats. Names like Darlene and Eric, they each pop up twice. It's kind of fun to spot these micro patterns. Now zip codes are a little less unique, 451 different zips, and if you dig even deeper, you see 90248 shows up 4 times, 10011, 94104, etc. They each occur 3 times, and several others repeat. This is the point where, if you're working in ETL or building profiles for downstream analytics, you need to decide, what do these small clusters mean? Are they errors, or are they reflecting some business reality? Actually, I remember on a past ETL project, we had this huge problem with some zip codes being massively overrepresented. We assumed it was a bad import at first, but turned out those were all satellite offices for one big client. If we hadn't double-checked, it would have thrown all our market coverage stats way out of whack. So, small patterns, but big implications if you miss them. It all circles back to why careful data profiling matters. Whether you're working with contact info, health recovery progress like we talked about last time, or building AI automations, understanding where your data is unique and where it clusters can keep your models honest and your analytics reliable. Well, thanks for hanging out and letting me nerd out on column level stats today. We'll keep digging into real-world data sets in future episodes, so if you like this mix of numbers and stories, stick around. Until next time.
All right, let's play detective for a few minutes. We've just been handed a case file, but it's probably not what you're thinking. It's just a single, pretty simple data file. Our mission, should we choose to accept it, is to crack this thing wide open and find the story that's hiding inside. So let's get right to it. And here it is, the piece of evidence itself. I mean, at first glance, this is just a wall of technical nonsense, right? The US_500 table in the DBO schema. It sounds complicated, maybe even a little bit boring. It's just data. But that's the real question, isn't it? What is this thing really telling us? Sure, it's a list of 500 people who live in the US, but is it just a totally random list? Or is there a pattern, a secret story buried deep inside all those numbers and names? Well, that's exactly what we're going to find out. Okay, so with any investigation, the first thing you have to do is survey the scene. You got to know what you're working with. So let's break this file down into its most basic parts and just size up the situation. First thing you need to know, everything is in one single database. You can think of this as the one big filing cabinet for our whole case. It's super important because it means all the clues, every piece of evidence, it's all right here. Nothing's missing. Now, inside that one filing cabinet, there's just one folder. In the data world, we call that a table. This tells us our investigation is really focused. All our case files are in this one spot, and its name, US 500, gives us our first real clue. We're probably dealing with 500 of something. And yep, that brings us to the rows. There are exactly 500 of them. Each one of these rows is basically a case file for one person. So this isn't just one big case, it's 500 little ones that we need to look at. And for every single one of those 500 people, we have exactly 12 pieces of information. These are our columns. Think of them as the 12 standard questions that every single person in this file had to answer. This is our framework. This is the structure for our entire investigation. So what are those 12 pieces of info? Here's the whole list. We've got the basics like names and addresses, but also company names, emails, a couple of phone numbers. You get the idea. This right here, this is our evidence logger. These 12 categories are literally all we have to go on to figure out the story. Okay, so we've got the lay of the land. We know what our evidence looks like. Now, the real work begins. We're going to stop looking at what the data is and start asking what it tells us. The key to cracking this whole thing is finding the patterns. This is where things get really interesting. We can sort all our evidence into 2 buckets. On the left, we have what I'm calling unique fingerprints, things like email addresses and phone numbers. For these 500 people, pretty much every one of these is unique. But on the right, we've got shared clues, things like the state they live in, the county, the city, even first names. Lots of people share these details, and that's our opening. See, the unique data tells us about individuals, which is fine. But the shared data, that tells us about the group. And the story of this file isn't about one person. It's about the connections, the things they have in common. The shared clues are where the real story is hiding. So let's follow that trail. This is it. You know, it's that moment in every detective movie where one little thread starts to unravel the whole mystery. By focusing on those shared clues, we're about to find some serious hotspots. This is our big break in the case. And boom, here it is, our first huge discovery. We just looked at the states column and wow, just look at this. Out of all 50 states, a massive number of our 500 people are jammed into just 3. 72 in California, 52 in New Jersey, and 46 in New York. This is not a random sample of America, not even close.
Let's just let that sink in for a second. If you add that up, that's 170 people, over a third of the entire dataset, from just 3 states. This is a massive clue. It's a giant, flashing red light telling us that this group is not what it seems on the surface.
And the trail doesn't go cold there. It actually gets even hotter when we drill down to the county level. The top 3 are Los Angeles County, New York County, which is basically Manhattan, and Cook County, which is Chicago. Do you see the pattern? We are seeing a huge concentration in major cities. So what we found here actually has a name. It's called a data hotspot. It's just a spot in your data that has a surprisingly high number of, well, anything. It's the data's way of waving its hands in the air and yelling, "Hey, look over here. This isn't random." And we've just found a bunch of them. All right, we've followed the clues. We've uncovered the hotspots. Now it's time to put it all together, present our findings, and officially crack this case wide open. Let's reveal the story that was hidden in the data this whole time. So the main conclusion, the headline, is simple, and it is direct. This dataset is not a random sample of America, not by a long shot. That initial appearance of just a simple list of people was totally misleading. So what's the real story? Well, first, these 500 people are massively concentrated on the East and West coasts. Second, huge cities like LA, New York, and Chicago are way overrepresented. And from all that, we can make a really good guess. This isn't a snapshot of the whole country. It's much more likely a list of urban professionals, not an average cross-section of the US population. Case closed. You know, the bigger lesson from our little investigation is this really powerful idea. We started with a file that looked like nothing special, just a boring spreadsheet. But by knowing how to ask the right questions, by looking for those patterns and hotspots, we found a really clear story. And it proves that every single dataset has a story to tell. You just have to know how to look for it. And that brings us to the final question, the one I really want to leave you with. We just cracked the code on this one file, but this way of thinking applies to everything. So the real question is, what stories are hiding in your data? Thanks so much for joining me on this one.